In the vast silence of space, most stars live quiet lives. They are born, they burn, and they die. Predictable, consistent, obeying the rules we've come to understand. But once in a while, one of them breaks the rules. One of them behaves as if something's wrong, or as if something else is there. Tabby's star is that outlier, an enigma that defies our models, challenges our logic, and whispers a possibility that has long been taboo in mainstream science. A star that doesn't just dim. A star that dims without cause, without rhythm, and without reason. A star that might, just might, be telling us we are not alone. It started innocently enough. Kepler, NASA's space telescope, launched to find planets, was staring at a patch of sky, gathering light from 150,000 stars. It watched each one like a lighthouse keeper watching for a ship. When a planet passed in front of a star, Kepler would catch the dip in brightness. Simple, predictable. That's how we found our first Earth-sized exoplanets. But then came KIC 846-2852, a star buried in the catalog, just another dot in Cygnus. When researchers studied its light curve, they didn't see a smooth, shallow dip like a planet's transit. They saw jagged, massive plunges in brightness. Sometimes it dropped by 3%, then nothing, then a 15% drop, then 22%, then weeks of silence. No pattern, no orbit, no symmetry. Planets couldn't explain it, not even big ones. Even a Jupiter-sized planet blocks only about 1% of its host star's light. What they were seeing, repeated, irregular shadows, defied natural explanation. Dr. Tabitha Boyajian, the star's lead investigator, couldn't ignore the anomaly. The team ruled out bad data. They ruled out telescope error. What remained was something truly strange. They published the findings in 2015. The scientific community took notice, and the star got a new name, Tabby's star. Scientists, by nature, seek conventional explanations. The universe is vast, yes, but most of it runs on well-known rules. So they turn to the familiar. Could it be a swarm of comets? Perhaps a family of icy bodies was shedding dust as it passed in front of the star. That could explain irregular dimming, right? But to block over 20% of a star's light, the comet swarm would have to be unprecedentedly large and perfectly aligned from our point of view. Also, there was no infrared signature, no evidence of warmth from dust that close to a star. So, maybe planetary debris. Two planets colliding, sending a cloud of rubble across the star's face. Again, that much material would radiate heat, but no heat was found. What about the star itself? Some unknown stellar process we've never seen? But F-type stars like Tabby's are stable. No known mechanism inside a star can dim it by 20% with no thermal output. And what's more, the weirdness didn't stop with the Kepler data. Historical records, including photographic plates from the early 20th century, showed a long-term dimming trend. Over the last century, Tabby's star has faded by nearly 20%. That's not just a dip. That's something accumulating. None of the known, natural explanations fully fit the data, which led some to ask, what if it's not natural at all? In 1960, physicist Freeman Dyson proposed a radical idea. As civilizations grow, their energy demands will eventually outstrip their planet's resources. At that point, they might begin harvesting energy directly from their star. They might construct a Dyson sphere, a structure, or more realistically a swarm of solar-collecting satellites that orbits the star and captures a portion of its light. Such a megastructure wouldn't be a solid shell, but a loose, expanding cloud, constantly shifting, orbiting, adjusting. And it would block starlight irregularly. Dyson never said aliens were out there building them. It was simply a logical endpoint of technological evolution. But now, decades later, Tabby's star presented a light curve that looked strangely similar to what a Dyson swarm might produce. It wasn't proof, far from it, but it was enough to take seriously. Suddenly, the realm of SETI, the search for extraterrestrial intelligence, wasn't just about listening for messages. It was about watching for engineering. The next step was obvious. Listen. If a civilization capable of building stellar-scale structures was orbiting Tabby's star, perhaps they were also communicating. So the Breakthrough Listen project, a $100 million effort funded by Yuri Milner and backed by scientists like Stephen Hawking, turned its most sensitive radio telescopes to the sky. They listened for months, for beacons, pulses, code, any deviation from natural radio emissions. And what they found was silence. No signal, no ping, nothing artificial. But silence doesn't mean absence. It may mean stealth, or disinterest, or communication through means we don't yet comprehend. Quantum channels, neutrinos, or something far more advanced. We expected them to announce themselves in ways we could understand. But maybe that's our mistake. Tabby's star forced a shift in thinking. If we're truly looking for alien civilizations, we may never see spaceships. We may never hear a signal, but we might see their impact. A technosignature is not a greeting. It's not a message. It's a side effect, a byproduct of intelligence. Waste heat, atmospheric chemicals, massive construction projects. And Tabby's star is now the prime suspect in our search for these signs. It became the first star in modern SETI history to be observed not for its light or its sound, but for its shadows. Not just any shadows, but shadows that suggest design. What if the star isn't dimming randomly? What if we're watching the silhouette of machines, vast, slow, methodical, passing in front of their sun? And what if the civilization behind them is gone? A dead race, long expired, whose machines continue their program without masters, silently orbiting in the dark, unaware that someone, light years away, is watching. Years have passed. New data continues to arrive. The mystery remains. Tabby's star continues to flicker, not as dramatically, not as frequently, but the long-term fading trend continues. And we still don't know why. We've launched more powerful observatories, JWST, the upcoming Nancy Grace Roman Telescope, the massive square-kilometer array, all of them capable of helping us monitor stars like Tabby's with unprecedented clarity. At the same time, machine learning algorithms comb through the mountains of telescope data, looking for other stars that might behave the same way, others that hide their secrets in the light. And every time we find another strange star, we ask ourselves the question anew: is this natural? Or is this the signature of intelligence? Ultimately, we may never know what's causing the dimming. Maybe one day, a new model of stellar evolution will explain it. Maybe we'll find that a weird mix of dust, debris, and orbital quarks accounts for it. But even if we do, Tabby's star has already changed the game. It reopened the door to the serious scientific discussion of alien megastructures. It gave us permission to be curious again, to wonder, to imagine, responsibly, rigorously, but without fear. It reminded us that the universe is still full of questions we don't yet know how to ask. That intelligence, if it exists elsewhere, may not want to talk, but it might still be visible. In the dimming of a distant star, in the flicker of light across centuries, in the shadow of something vast, slowly unfolding.